Good afternoon. Today we're going to have a brief review of what we have discussed already before, the ARMA process, and then after that we go to ARIMA modeling already. So far we learned about what an AR, an MA, an ARMA process looks like. We looked at the equation behind it. We looked at its characteristics. So this one I already gave to you, but the file that I sent you just now also includes this for as a review. Okay, so quickly, what does an AR process, what are the characteristics, the overview? First, the formula is that you're regressing, you're developing a model of x sub t based on its past value. So the past value can be log 1, log 2, or whatever lag. Okay, if it's log 1, then it's an AR1 process. If there are two logs that you're using in order to model your time series, then it's a log 2 time series. Okay, so what's a log 1 time series? So if you have a time series, let's say, dating back to as far as 2010, daily data, for example, until now, October 18, a log 1 series will involve or include the data from October 17, okay, and then going up, okay? So that your regressor, your x sub t minus 1, will start with the data on October 17. Today is October 18. Your regressor, your x sub t minus 1, will start with October 17 and going up. Okay, and of course, we will have to remove one row, the last row from the x sub t, because it will have it will have one more observation. Okay, so the last observation will be removed to match the log 1 value. And what's the rationale for this? What's the rationale for an autoregressive model? The rationale is oftentimes data, in particular time series, are so related to each other so that the past values have an effect on the future values. Okay, so for example, here we're quote unquote theorizing that the values of yesterday impact the values of today. Okay, so that the value of today is affected by the value of yesterday, October 17. The value of October 17 is affected by the value of October 16. So ganun yung class, no? Ganun yung concept ng auto-regressive. Auto means self, regressive means regression or modeling. You're modeling your time series now based on its past values. Okay, so this can be x sub t minus 2. Okay, so that means two lags, both lag 1 and lag 2. If you have that model class, then you have what we call an AR2 process, which we studied before. Okay, now here you have the standard formula is you have this constant, and then you have this error term. Okay, this constant class, of course, it's a constant, so it's just a number, and we'll take a look at what this means later on. This phi class is your parameter. Okay, this is your parameter. In regression class, ito yung parang slope, no? Slope. This is just like class. Actually, this is just like a simple linear regression where you're using the log 1 in order to model and predict your time series x sub t. Epsilon sub t class is what we call a white noise. Okay, and where do we get this? This is from the residuals class. Okay, the difference between your actual value and this value class, the intercept plus your predicted value class, is your epsilon sub t. That's your residual. And the residual class behaves in such a way that it's a white noise. Okay, we'll explain as we go along what white noise is. White noise with mean equal to 0. Okay, and variance is constant, sigma squared. Okay, this is very important, the concept of white noise. Okay, now So x sub t is the observed value at time t. C is a constant term. Phi is the autoregressive parameter. Epsilon sub t is white noise with mean zero and standard deviation constant. Okay, now let me go down to look at the other characteristics of an AR1 process. Okay, this one class, very important. The theoretical mean. Okay, what is the theoretical mean? And how does it compare with the average of your x sub t? Okay, because you can compute for, you have your x sub t, right? You have your time series. You can compute for the average of that, the mean of that. That's what we call the mean of your x sub t, okay, by getting the average. Or it's also called the empirical mean, empirical mean. How do you get the empirical mean? Just get the average of your x sub t. Now, the theoretical mean is different. Okay, iba class yung theoretical mean. And it's denoted as mu. And there's a formula for that. It's equal to your constant C divided by 1 minus P. Okay, 1 minus P. And there's a condition, class. This will only be true, this theoretical mean will be true when phi is less than 1. Okay, so ang condition, class, ng AR process, sorry, hindi ko na talaga nakita yung ano, yung stylus ko, no. I'm still trying to find a replacement for that. As we said, AR1 process is equal to, okay, C plus your phi or phi1 times your x sub t minus 1, and then plus your error term, epsilon sub t. Now, this is very important, class, yung phi. The phi here has a condition, class, for it to be an AR process. Okay, the absolute value of phi should be less than 1. What does this mean, class? It can be negative and positive, but it cannot be more than 1. So it can be, for example, negative 0.9, or it can be positive 0.9. It can be negative 0.1, or it can be positive 0.1. Okay. However, it cannot be equal to 0. Why can't it be equal to 0? Because if this becomes 0, class, then you no longer have an AR process, right? Your x sub t now is no longer a function of your past values kasi 0 na to, di ba? Ano matitira? Yung constant lang. And your epsilon sub t. So wala na yung regressor na x sub t minus 1. So again, class, the phi cannot be equal to 0. Okay? Hindi siya pwedeng 0, no? Dapat hindi siya pwedeng greater than 1. Dapat yung phi natin, it should be less than 1, it can be negative or positive, and it cannot be greater than 1. So if this is, let me, balik nga ako doon, class, sorry. I need to go back there. This one, class. Okay. If this was less than, if this was equal to 0, class, 0 to, no? 0 yung phi natin dito, di mawawala to. So wala na yung AR process natin, class. Okay? No more AR process. Buti sana, class, kung AR2 yan, no? Kung AR2 yan, class, meron kang phi1 x sub t minus 1 and phi2 x sub t minus 2. Okay? So phi1, class, can be 0. Pwedeng 0 to. Okay lang na 0 yan, class. Kasi meron ka pa namang x sub t minus 2 na regressor, di ba? You can still relate x sub t with x sub t minus 2. Okay? But if it's an AR1 process, hindi pwede maging 0 to. Hindi pwede maging 1 yan, class. Why? Okay? I'll explain why it cannot be equal to 1, class. Kasi magiging C plus x sub t minus 1 yan plus epsilon sub t. Now, if this is 1, class, it will become like a white noise na siya. magiging white noise to. Okay? Hindi na siya AR process. White noise na siya. Parang equivalent na siya dito sa class, sa epsilon sub t. Okay? So, if phi is equal to 1, hindi siya pwede. No? Also, if phi is greater than 1, hindi rin pa pwede. Okay? Pag greater than 1 to class, magiging, ang tawag natin dyan, random walk. Okay, so for example, x sub t is equal to c, kunyari 3 plus 1.2 times x sub t minus 1 plus epsilon sub t. If that's your model class, then it becomes a random walk. Ang random walk class, ang behavior niyan, it's meandering. Hindi mo ma-predict yan, no? Kung saan pupunta yan, class. If there's a c here, if this is a value, it becomes what we call a random walk with drift. Drift class. D-R-I-F-T. Okay, let me repeat that, class. If x sub t is equal to, let's say, constant to, my value to, let's say, 3 plus 1.2 x sub t minus 1 plus epsilon sub t. Okay, this is no longer an AR process. Hindi na siya AR process kasi yung phi mo is greater than 1. So, ano mangyayari dito, class? Anong tawag natin sa magiging series na to? This becomes a random walk, no? With drift. Okay, because there's a presence of c here. If this was 0, class, kung walang constant, magiging ano yan, x sub t is equal to, let's say, 1.5 times x sub t minus 1, no? Plus a certain error term. Then that becomes a random walk class without drift. Walang drift kung 0 to. Okay, so I hope that's clear, class. Yung AR process necessitates that your phi should be less than 1. Sadali lang. Okay, so dapat less than 1 yung phi natin. Okay, klaro, class, paki-chat naman please kung if you need more explanation for that. Klaro ba yung sinasabi natin, yung equation na yan? Any questions? Okay, thank you. Okay, good. Thank you. So feel free to raise your hand if you have any questions, any clarifications. Do not pretend that you understood it. Okay, no question here will be treated as inferior or subpar. Lahat ng questions dito importante. Okay, so balik tayo dito, ah. Okay, so please, class, intindihan yung conditions ng AR process, and it will help you really appreciate or understand yung ARIMA modeling. Now, ito, class, ito, no? Balik tayo dito. Merong theoretical mean dito. Yung theoretical mean, class, it's the long run average. Okay? Theoretical mean, and it has a formula. Diba? So C over 1 minus theta. Okay, so kung walang intercept, class, kung walang constant, kung 0 siya, then magiging 0 to. So walang theoretical mean, walang long run average. Ano ibig sabihin ng long run average? Ibig sabihin niyan, class, especially for a long time series, kunyari mahaba yan, ilang hundreds, ilang thousands of observations, you will be able to compute kung ano yung average on the long run. So parang nag-fluctuate yung data dyan across the long term, no? Dun siya nag-fluctuate. Yun ang tinatawag natin na theoretical mean. Okay? Especially, class, this will be very important when we go to multivariate, no, time series. So that's your long run average, and it's different, class, from your average ng x sub t. Okay? Kunyari, kinuha mo yung average ng x sub t. Ba? Pwede mo naman kunin mean x sub t. Iba yung class, iba yon. Okay? Iba yung c over 1 minus phi. Yung theoretical mean na yan, as I said, class, it accounts for the long run average of your time series. Okay? Meron ding theoretical variance. This is also your long run variation ng time series natin, and it's equal to sigma squared, which is the variance of your x sub t. Pwede natin makuha naman to, di ba? Var ng x sub t. Ito yon. Pero if a factor mo yan ng 1 minus phi squared. Okay? Now question, ang ano ba, empirical variance, mas malaki kaysa kay ano? Theoretical variance. Can you answer that, class, please? What do you think? Sino mas malaki usually? Si empirical variance o si theoretical variance? You can get it from the formula, class. Dali lang naman yan. Anyone? Just a guess, class, please. So, based on the formula, who will be most probably, class? And this is certain man tayo dyan, no? Sino yung mas magiging mas malaki, class? Si empirical o si theoretical? Oh, madali lang yan, class. Any guess, class? Any guess? Take a look at the formula. Empirical, mas malaki. Okay, tingnan natin, class, no? Ano ba si phi, class? Di ba less than 1 to? Right? Kunyari 0.5. Kasi ang phi natin dapat, class, ano di ba? Dapat less than 1 yan if this is to be an AR process. 0.5. Square mo siya. 0.5 times 0.5, 0.25 yan. Okay? So 1 minus 0.25. So this is a decimal, class. Ba? Right? So this is less than 1. Kung 1 sana to, equal sila. Equal yung empirical at saka yung ano, yung empirical at saka yung theoretical. Kaso less than 1 to di ba? Right, so what happens to your quotient? Lalaki yung quotient nyo, class. Because this is less than 1. It will always be less than 1, class. Kahit negative yung phi nyo, class, no? Negative 0.5 times squared, 0.25 pa rin yun. Okay? So this will always be less than 1. Since this is less than 1, then your quotient becomes bigger. Kasi pareho lang naman yung sigma squared. Okay? So therefore, your empirical variance, class, your theoretical variance will be more or less greater than your empirical variance. Ibig sabihin, yung long-run fluctuation will oftentimes be bigger than your short-term fluctuation, which is the measure of your empirical variance, short-term. Okay, so let's go. Let's continue now. Then you have here the formula, class, for autocovariance function and autocorrelation function. Mamaya i-discuss natin to, class. Itong autocorrelation function na to. Okay? Ang importante dito, class, yung stationary condition. Ito. Okay, may mga answer pala kayo, no? Okay, that's theoretical ang answer, no? Okay. Thank you for your answers, class. Okay, ito, class. Stationary conditions, we already discussed that. Yung phi minus 1. Babalikan ko, class, yung condition ng stationarity, although na-discuss na natin to, no? Yung AR1 process, yung AR process, class, kailangan stationary yan. Later on, I'll go back to the stationary requirement from an AR1 process. Okay, this one I gave already, no? Ang ginawa ko, class, binigay ko na sa inyo yung file kung saan ko kanina in my other class, kinopy-paste dun sa R para hindi na tayo magtatagal kasi kanina natagalan ako kasi minsan ayaw ni Zoom na i-send yung marami-raming lines of notes, no? So I gave you some notes about the theoretical mean. So sabi ko nga sa inyo, class, yung theoretical mean ng AR1 process, long run average value yan. Okay? Ibig sabihin nun, on the long run, class, on the long run basis, the time series fluctuates around that value, around that mean. This theoretical mean represents the expected value of the process over time, assuming it's stationary. Okay? So, magkaiba, class, yung arithmetic mean kaysa theoretical mean. Okay? I stated here, class, that empirical mean can be affected by short-term fluctuations and may not accurately represent the long-run behavior of the process. Okay? Especially for shorter time series. So, class, si mean, si empirical mean, greatly affected yan ng, especially pag short-term. No? Ang long-term, class, it's not affected by short-term fluctuations. Okay, so yun ang important, class. Magkaiba sila. Now, however, pag mahaba yung time series natin, kung very long yung time series natin, sorry, sabi ko dito, the empirical mean might approach, no? Take note of this, might approach. Ang ibig sabihin ng might approach yan, might approximate. Pero hindi sila talaga nagiging equal. Okay? It might approach the theoretical mean. However, they are conceptually different and often not exactly the same, especially for shorter series or those with strong autocorrelation. Okay, so there's a difference between theoretical mean and empirical mean. Okay, next class we go to, naibigay ko na naman sa inyo dati to class, no? Tingnan na lang natin very quickly itong AR2. Okay, so yung AR2 class, as we know, class, yung equation yan, dalawang logs ka. Dalawang logs. Okay. xt minus 1 and xt minus 2. Okay, may nakalimutan akong i-discuss kanina. Di-discuss ko na ngayon. Now, so ang x sub t natin, class, ba? This is our time series. This is your constant and this is your white noise. Remember the white noise, ang distribution yan, class, zero mean and constant variance. So, ibig sabihin yan, class, pag plinat mo yung white noise na yan, okay, sorry, ngari plinat natin siya, ganito yung itsura niyan. Parang ganyan siya. Okay, it should behave that way, no? And then ito yung zero. Zero. So nag-fluctuate yung yung value niya sa zero. Zero mean di ba? Average na zero. And then constant yung variance. Ibig sabihin, hindi siya lumalaki over time na ganyan o hindi siya lumiliit na ganyan over time. So ganyan lang siya, class. Yung ano niya, yung yung let's say yung high and low values, class, remains constant over time. Yun ang ibig sabihin na constant yung variance niya. Okay, white noise. Mamaya, di-discuss natin si stationarity. Ganito din, hindi naman zero, no? Hindi zero, class. Constant mean ang AR process, but not necessarily zero. Okay, so ito, class, phi1, phi2. So dalawa na yung regressors natin. Dalawa na rin yung parameters natin. Now, yung models na ganito, class, it can be written using what we call a backshift operator. Although na-discuss ko to last time, ano? Sabi mo nga, tinan nyo to yung backshift operator na to. So let's just write this in terms of a backshift operator. So ang gagawin natin dyan, ipagsasama natin lahat ng x sub t on one side. So x sub t minus phi1, x sub t minus 1, minus phi2, x sub t minus 2. Okay, I'm sorry for the handwriting, class. Ang hirap sa mouse. So, transpose ko lang to sa kabila, and it's also, of course, equal to c plus epsilon sub t. Okay? So, natira lang tong class yung c at saka epsilon sub t dito sa right-hand side. Yung left-hand side, linipat natin to at saka ito. Okay, now, take note, class, that pag sinabi natin backshift operator B ng x sub t, that's actually equal to backshift. Maglalag ka ng isa. X sub t minus 1. Yan. If you write b squared ng x sub t, dalawang lag siyan, class. Kaya x sub t minus 2. Okay, pag b squared. So ito, class, okay, let's simplify this. So we want to write this in terms of a backshift operator. Okay, so factor natin sa x sub t dito. Right, x sub t here, x sub t. open and close parenthesis. So this is 1 to, no? 1. Distribute mo, x sub t yan. Minus phi1, okay? And then, x sub t1 to, minus 1, di ba? I can write this as b. B. Kasi class, pag dinistribute ko to dito, magiging phi1 times b x sub t. Take note that b times x sub t is equal to x sub t minus 1. So tama to, no? Okay, x sub t minus 1, we represented it by b times x sub t. Naka-factor lang si b sub t. And then minus phi sub 2, okay, b squared. Bakit b squared? Kasi class x sub t minus 2 to. Dalawang beses ka magkukuha ng log, no? B tapos another b. So b times b squared yan. Okay, and then this is equal to c plus epsilon sub t. Your white noise. Okay, so that's how you write your AR, or whether it's AR or MA process with a backshift operator. Okay? So pag nakita nyo ito, no, kunyari ito sa paper, isang paper o sa isang textbook or whatever, alam nyo na. Pag dinistribute nyo to, class, b times x sub t, that's x sub t minus 1. Okay? B squared times x sub t minus 2 yan. Okay? So you're just regressing your x sub t on its past 2 values. So that's an AR process. With the parameters phi1, phi2, constant c. Okay. Let me pause for a while. Questions, class? Maliwanag ba? Any questions?
Sir, paano nga uli magiging backsheet operator na may square siya?
Backshift, backshift.
Backshift. Sorry.
Backshift, no? Shift, S-H-I-F-T. Okay? Ulitin natin, ha? So, di ba, ito yung equation natin. Take note that B times x sub t. Backshift operator ng x sub t, this is equal to x sub t minus 1. Parang ang ibig sabihin niyan, ilag mo ng isa si x sub t. And the log 1 of x sub t is x sub t minus 1. So pag sinabi mong b squared x sub t, dalawang beses mo ilalag si si x sub t, and that's equal to your x sub t minus 2. Ayan. X sub t minus 2 yan. Okay? So if this is our equation, then sabi ko nga, di ba, i-transpose natin lahat ng mga x sub t's on the left-hand side. And then matitira sa right-hand side yung c at saka epsilon sub t na lang. So anong mangyayari dyan? X sub t, okay, minus p1, x sub t minus 1. Diba? Kasi pinunta natin, we transposed it, minus p sub 2, x sub t minus 2. Okay, so yan yung left-hand side natin. So I can factor out x sub t. So open parenthesis, close parenthesis, x sub t. So finactor out ko si x sub t class. Of course, the first item here will be 1. Kasi 1 times x sub t, ito yun, no? X sub t. And then minus p, which is this one. What is x sub t minus 1? X sub t minus 1 class, di ba, is b times x sub t. E may x sub t na tayo dito. So if we distribute this here, magiging phi times bx sub t. But remember, bx sub t class is x sub t minus 1. So okay to. Okay, and then minus phi sub 2. Then x sub t minus 2, dalawang logs to, no? So b squared yan, b squared. And then x sub t is here. Pag i-distribute mo siya dito, b squared times x sub t. But remember, b squared times x sub t is x sub t minus 2. So which is this one? So tama ito. Tama yung equation natin. And this is equal now to c plus epsilon sub t. Okay, did that answer your question?
Yes, sir.
Okay, thank you for that question. Any other questions, class? Pasensya na kayo, class, until such time na hopefully, kung hindi ko na makita, class, if you know a place, class, where I can buy yung mga ang tawag ito, yung mga stylus for digital writing pad. Yung sa akin kasi Huion Huion, matagal ko na rin 'to nabili. Digital writing pad siya. Tapos hindi ko makita yung yung digital pen. Mas madali sana magsulat dun para mas legible pa yung Ito kasi nagma-mouse lang ako kaya ang hirap. Ang hirap magsulat sa mouse. Okay, so clear natin 'to. Okay, close ko na 'to. Okay. So you can also compute for the theoretical mean ng isang AR2 process, no? It's also equal to C over 1 minus V1 minus V2. Okay? So if you have an AR2 process, ando dun yung C mo, yung constant mo, may V1 ka, may V2 ka, then if you're asked, what is the long run average of this time series? Madali yun. It's equal to mu is equal to C over 1 minus V1 minus V2. Okay? Yung long run variance naman, medyo mas mahirap, no? Tingnan niyo yung formula. Medyo medyo mas complicated. Okay? Kasi may 1 minus V2 tayo dito, tapos yung variance ng time series, tapos ito. Okay? So, don't have to memorize those formulas. And then, meron tayong autocovariance function given by this formula. So, you notice pag AR2 process, mas complicated siya, no? Okay? And also, ito importante, class, yung stationarity conditions. Okay? Dapat yung mga V1 and V2 natin, in order for this to be an AR process, dapat yung sum ng V1 at saka ng V2 dapat less than 1. Hindi siya pwede maging greater than 1. Otherwise, magkaka-problema yung natin, yung theoretical mean. Okay? Kasi, tapos hindi rin siya pwedeng equal, no? Kasi pag equal yung V1 at saka V2, then this will become, pag equal to 1 pala sila, no? This will become 1 minus 1. So magiging 0 to. Hindi pa pwede maging 0 yung denominator dito. So that sets this equation na hindi pa pwede yung pag inad mo si V1 at saka V2 equal to 1. Okay? So these are the conditions for stationarity. Bakit may stationarity, class? Okay? Kasi pag hindi stationary yung series mo, okay, ibig sabihin, kunyari, yung V1 greater than 1, wala na, hindi na yan. Hindi na pwede sa autoregressive yan. Okay? Pag random walk kasi, class, ibig sabihin, nagme-meander siya, no? Umaakyat, bumababa. Okay? Hindi constant mean yun. Okay? Nagme-meander siya kung saan siya pumupunta. You cannot use ARIMA for that. Okay? Therefore, your ARIMA will not work if you have a random walk. So, if you plot it and you see that it's a random walk, then we cannot use ARIMA model for that. Okay, so in general, class, so general lang to, no? Ito yung yung general natin na AR process. Diba? By the way, kausap ba ako ng MA? Hindi pa. So punta muna ako dito sa ARP process. No? So this is logs of P, class. Log of P. V1, V2, up to V sub P. Okay? Kung ARP, therefore there will be P parameters, no? V1, V2 hanggang V sub P. Ito yan, class. Okay, and then also we can also compute for the theoretical mean. Yung theoretical mean ganun din, C over 1 minus V1, V2, etc. Okay, and theoretical variance medyo complicated to. And it makes use of what we call the Walker equations. Mamaya, class, parang umabot tayong bilis ng oras. When we reach yung partial autocorrelation functions, I'm going to discuss itong Walker na to. Okay? And then we have auto-covariance and also autocorrelation. Discuss natin mamaya si autocorrelation. And then, tingnan nyo to class. No? So ano dapat yung stationarity conditions? Okay. 1 minus phi1, phi2, phi3, etc. Di ba? Saan nakuha to class? Nakuha to dun sa sa backshift operator class. Ito. Okay, dapat when we draw a unit circle class, so ito yung mga roots of the roots of the equation, no? So this is your unit root. This is your circle. Okay? This has a radius of 1 to. Dapat class yung mga solutions natin na phi1 dito, phi1, phi2, wala dapat is equal to 0, should lie outside the circle. So dapat andito yung mga values sila. Okay? Should lie outside the circle. Yun ang sinasabi dito. Tingnan ko sa later. It should lie outside the unit circle. Lagyan ko nga ng ano to. Sobrang haba. Next line ko to. Anyway, class. Anyway, sige. Sa ako, i-decide mo. Okay, then let's take a look class at an MA process. Diniscuss na rin natin to. I'll just discuss up to MA1 class kasi I just want to point out something here. Okay. MA1 class. Itong notes na to, itong invertibility, nasa nasa text file na sinend ko sa inyo. No? So lahat ng i-discuss ko, lahat ng mga notes doon, ando doon na sa class. So it's best that as I discuss, pwede nyo i-copy paste dun sa R nyo. Okay, so this is your MA process. Binigay ko na naman yung formula ng MA process. You can just put here yung notes dito. Okay, tingnan niyo yung formula class ng MA1 process. Note na hindi to C, no? Mu na to, which is your long run average already. So the MA process will already give us the mean of the process. Unlike yung AR process, di ba? Kasi constant pa lang yun. So for the AR process, you have to compute C over 1 minus C kung AR1 process to get your theoretical mean. So MA process class, ito na yun siya, na binigay na. Okay, plus your residual white noise, and then this one is also your, lahat ng mga epsilon sub t white noise yan. Okay, yan o. Epsilon sub t are white noise terms with mean 0 and constant variance. Ito yung parameter natin. Okay. All right. So now some things, there's one very important aspect about itong MA, moving average. Yung epsilon dito class, yung residual, hindi galing yan sa AR process ha. Kasi di ba when we think about it, baka isipin natin, yung epsilon dyan, galing siya sa AR process, tapos yung error dun sa AR process, dito linalagay. Okay, that's not the case, no? Itong epsilon sub t na to class, medyo kinocompute yan, no? Kinocompute yan in such a way that may objective, no? Ang tawag dyan class, yung one method is what we call MLE, okay? Maximum likelihood estimation. Okay, pero hindi na natin i-ano yun kasi medyo involved yung steps na to, no? But just be aware that yung mga ano ito, yung mga epsilon dito, these are computed. Kino-compute yan. Okay, using several methods like MLE, log likelihood, maximum log likelihood, etc. Okay, and then and then let's go down here. Okay, theoretical means, sabi ko nga, di ba? Is equal to mu. Given na yon dun sa model. Tapos theoretical variance is 1 plus theta squared times sigma squared. So you can see here, class, that ito, yung theoretical variance talaga ng MA1, mas malaki talaga kaysa kaysa sigma squared. Kasi 1 plus theta squared will be greater than 1, di ba? Ang theta natin, class, kung less than 1 yan, if it's less than 1, pag in-square natin yan, okay, pag in-square natin, pero pag dinagdagan natin ng isa, 1 plus ano pa rin yan? 1 plus a certain number. Okay? And 1 plus a certain number, multiply that by your variance, will still be greater than your variance. Okay? It will be greater than your variance. So you can see here that your theoretical variance or your long run variance, class, will always be bigger than your empirical variance. Okay, so here, class, kita natin dito, ganun din, class, yung may condition tayo dito. Theta should be less than 1 din, yung absolute value niya. So parang pareho to ng phi, no? Kaso, class, ang tawag dito, invertibility. So this is something very interesting, class. Ano ibig sabihin ng invertibility na to? Okay? What's the meaning of invertibility? Ang ibig sabihin, class, ng invertibility, sandali, i-delete ko lang to. Okay. Here. Alright. Nabigay ko na rin to, class, sa notes. The invertibility process, okay, ibig sabihin, class, si MA process, pwede yang gawing AR process. So parang ano sila, invertible tong dalawang process na to. So an AR process can be inverted into an MA process, and an MA process likewise can be inverted into an AR process. How does it go, class? Ganito yung formula niyan, class. So sabi natin dito, infinite AR process. So si MA1, pwedeng maging infinite yan, class, infinite na AR process. Take note, MA1 lang, ang equivalent niya, infinite na AR1 process. Ganun yun, no? So ito, ang formula niya, x sub t is equal to the sum of, ito yung theta natin, di ba? Yung parameter natin. And then take note, class, hindi siya minultiply sa epsilon t. Minultiply siya sa x. Okay? Sa previous, sa time series mismo, no? So ano ibig sabihin to, class? Di ba AR process to? You're regressing x sub t, you are modeling x sub t based on its past values. So, si MA1 process, class, equivalent nito. And that one, class, is infinite yan. So parang ganito siya. So this is another way to write it. So your x sub t is equal to your residual at time t minus theta x sub t minus 1 plus theta squared x sub t minus 2, then minus ulit. So nag-alternate, no? Kapag raised to the power even number, plus siya. Kapag odd number, minus. Theta 2, x sub t minus 2, minus theta 3, x sub t minus 3, plus theta 4, x sub t minus 4, minus that, hanggang infinite yan. Okay? So ang lesson dito, class, an MA1 process can be inverted into a infinite AR process. Okay? So naulit lang to. So we were expressing yung yung equation natin in terms of x sub t na, no? Okay. So let's end there, class. Yun lang gusto kong quick review natin, no, about that. So let's go now to our ARIMA process kasi no, Parang konti na naman yung oras ko. Okay. So yung first, ito class na send ko na rin dun sa ano, I think I asked you to read about Box Jenkins approach. Si Box Jenkins class, sila yung nagsimula ng ano, sila na yung nag-develop ng ARIMA process. Okay? So as the name suggests class, AR stands for past values, tapos MA stands for past error terms, tapos dali lang class ha. Okay. Okay. Sorry class ha. If there's noise, pasensya na medyo may nag-aayos kasi. Okay. AR, past values of itself. MA, past residuals. Itong integrated, hindi ko pa na-discuss, no? Integrated. Ano ibig sabihin yan? Okay. Now, ang unang requirement class for us to be able to use an ARIMA process is that the time series should be stationary. Okay. Kanina, na-mention ko yung stationarity. Okay, di ba? Kailangan stationarity yung data. So, what does that mean? Pag stationary data. Stationary data class means, okay, so you have here your time series. Ibig sabihin yan class, constant mean, constant variance. Constant mean, constant yung variance. So if you plot that, how does that look like? So ganito yung itsura niya class. Yan. Take a look at this class. Okay, yan yung time series natin. Ito yung mean niya. So notice na, well, of course, nag-fluctuate siya. No? Hindi naman eksaktong ganun lagi yung value. But on the average class, ito yung mean niya. Constant yan. Constant mean. Okay? And also constant yung variance. Ibig sabihin class, ito yung band natin class, BAND. Hindi siya lumalampas diyan. Meron sigurong konti, may konting ganyan, pero generally ganyan lang siya. Now, how does a non-stationary data look like? Sabihin natin non-constant mean. Ang magiging itsura ng non-constant mean class ganito. I'll put it here. Okay? This is your data. Non-constant mean yan, no? Bakit siya non-constant mean? Kasi if I divide the data into several sections, okay, kunyari dito, dito, tapos dito, tapos dito. Notice na magkakaiba yung average siya. Ito ang average ito. Dito sa section na to, ito siguro average dito na. Dito sa section na to, ang average dito na class. You notice, nagbabago na yung average niya, hindi na constant yung mean. So in other words, class, kapag may trend, whether going up or going down yung trend, hindi constant mean yan, class. So if you see a time series data and then you see that, Hindi lang class, ha? Sorry class for the disturbance. Okay, so may trend to class, hindi constant mean yan. How about non-constant variance class? How does it look like? Okay. Pwede naman class yung mean natin constant. No? Yari ganyan. Ganito yung data natin, constant mean. Kaso class, anong nangyayari class? Ganito. No? Oh, constant mean, pero yung variance natin hindi constant. Dito sa portion na to, ang variance natin hanggang dito lang. Pagdating dito sa portion na to, class, dito na yung variance natin. Ito na, oh. Yan na. Okay? So, ibig sabihin, class, pag yung data natin parang may fanning out, ganyan, o may fanning in, papasok na ganyan, to, fanning out, gumagano yung data. Or fanning in, lumiliit yung variance niya. Non-constant, not stationary yan. And worst class, it can be a combination of both. No? Clear natin. So, pwedeng combination ng non-constant mean non-constant variance. So, this is your timeline. Okay? So, your data is going this way. Diba? Class? Diba? May trend na siya. Hindi po constant yung yung variance. Right. So, pag ganyan class, anong gagawin? We cannot use ARIMA. No, no, no. Hindi pa pwede, class. Hindi pa pwede. We cannot use ARIMA kasi sa ARIMA class, kailangan ang condition dapat stationary yung data. Therefore, class, we have to transform our data and make it stationary. Okay? So, tandaan niyo ang class, ha? Make it stationary. Okay. So, sometimes, class, yung let's say, may trend, kunyari, may trend yung data natin, no? So, it's going this way. One way to resolve this is to get the difference of the data. Ano yung difference of the data? O kunyari, 10, 8, 9, 7, 8, 11, 10. Kunyari, ito yung data natin. No? Ito yung time series natin. This is the latest. To get the difference means just to subtract. So, yung pinaka-later value, 10 minus 11, that's negative 1. 11 minus 8, this is 3. 8 minus 7, that's 1. 7 minus 9, that's negative 2. 9 minus 8, that's 1. 8 minus 10, that's 2. So what happens, class, is that you have now a new time series. Ito na. Ito na yung imo-model natin, class. Okay? This is now what we're going to model. Yung difference time series. Now, when you difference it, class, ito yun. You're integrating it actually. So now, ang magiging model mo niyan, ARIMA, okay, ARIMA, PDQ na yan. Okay? P for your AR, D for your differencing, and Q for your MA. D now is 1 here. Okay, 1. Assuming, class, na when we difference, naging stationary na to, no? So you're modeling actually this difference D X sub T. Okay? A difference time series. Now take note. Okay, kunyari, minodel natin to, yung difference time series. So you were able to come up with a model, you were able to forecast. Now, take note, class, ha? Pag nag-forecast tayo, ang mga values natin na makukuha will be based on this. Eh, hindi naman yan ang kailangan natin, di ba? Ang kailangan natin yung ifo-forecast natin yung original data. Kunyari, sales to. Eh, bakit mo ifo-forecast yung difference time series? So, there's a way to revert back, no? To revert back to the original data para ma-convert natin yung forecast natin to the original data. Okay? Just saying, no? So, baka isipin nyo, difference time series, paano yun? Kung mag-forecast ka dyan, ganyan yung mga values yan. So, what's the use of that? Kunyari, sales tone, as I said, di ba? Don't worry, class, kasi pwede ibalik yan dito sa original time series para yung forecast natin relevant, no? Kasi based siya dito sa original time series. Okay? So, okay. Now, sometimes, so sabi natin, anong gagawin? Plot mo siyempre muna. It's stationary. First step talaga yan. Kailangan makita natin visually using plot kung stationary yung time series natin. Then next, kung hindi stationary, then we have to do some transformation. Okay, anong unang gagawin? Okay? If there's a trend, class, i-difference natin. Okay? I-difference natin. And usually, pag dini-difference natin, class, nawawala yung nawawala yung trend, no? So that can cure the trend. Okay, so differencing, no? So yung ARIMA natin yan, yung PDQ natin, yung D natin, 1 doon, no? Kasi nag-difference tayo. Okay. So that can cure the trend. Now what if, class, what if may hindi constant yung variance? Pag hindi constant yung variance, class, no amount of differencing kahit twice differencing ka pa. Kasi pwede yun, class, eh. Kunyari, trend lang, Tapos wala namang constant naman yung variance niya. Tapos first differencing, hindi pa stationary. Pwede ka ulit mag second differencing, no? Pero usually class, first differencing okay na. Pag hindi pa pwede, mag second ka. And usually matitreat na yon yung trend natin. Okay? Now, what if there is non-constant variance? No amount of differencing will cure that class. Hindi yan maku-cure. Kahit ilang differencing ka pa. Laging may hindi constant yung variance yan. The differencing will not cure the non-constant variance. So what's usually done? Other transformations. One of the most popular one is to get the log transform. So kunin mo yung log class. Kunin mo yung log ng data. Anong purpose? Para yung data natin, matransform natin so that the variance will be constant. Okay? I'll show that in a while, no? All right. Now, what if kailangan mong gawing pareho? Kailangan mong gawing kasi meron siyang trend at saka may seasonality. So anong gagawin natin kung kailangan natin gawing pareho? So either, 'di ba, kukunin natin yung first is to treat the trend, you get the difference, no? And then to treat the covariance, the variance, you get the log. So pwede yan. So kunin mo muna yung difference, tapos kunin mo yung log. Now, warning, this will not work. Hindi mag-work to. Bakit class? Sabihin ko na yung reason ha. Pag kinuha mo yung difference in class, magkaka-negative yan. Chances are magkaka-negative yan. And when you get the log of a negative number, wala na, error na yan. There's no such thing as the log of a negative number. Okay, so you do not do this class. You do not get the difference and then you get the log. Reverse mo yan, class. You get the log first and then you get the difference. That's the way to do it, class. Okay? So hindi difference log, but rather log difference. Kung gagawin mo sa R yan, parang difference, and then log. Parang ganyan yung yung transformation ng x sub t. Yan. Ganyan yung code yan sa R. Diff log. Hindi log tapos diff. Kasi dito mauuna yung difference, no? Diff ng x sub t. Dito mauuna yung difference tapos saka mo ilolog. Sabi natin this will not work. What will work is get the log first and then get the difference. Okay? So pag ganun class, pag not stationary in mean and in variance, you might do both things. Okay. So ngayon, pagkatapos natin class magawa yung transformations, no? Once we are able to do the transformations, pwede na natin class, of course, i-plot nyo ulit, tapos mukhang stationary na, hindi pa pwede yung visual lang, kailangan statistically itatest natin. Okay? So this one, kailangan statistically test using either, this is ADF test or augmented Dickey-Fuller test. Dickey-Fuller from the person who developed this. Dickey-Fuller, D-I-C-K-E-Y Fuller. Or also, a more powerful KPSS test. Kwiatkowski, Phillips, whatever, no? Apat na names yan, test. Okay, so we can use this in order to statistically test kung stationary siya. So do not just depend on a visual inspection. Hindi lang natin pwedeng tingnan kung stationary ba yan? Stationary in mean and stationary in variance just by looking at it. Kailangan may statistical test. Alright, then next class. Next is, ang gagawin natin ngayon is ito na class. Ito na yung sinasabi ko kanina. Create the autocorrelation and partial autocorrelation function. Ito. So madali lang to class, yung autocorrelation function. Ganito lang yan, no? So kunyari may data ulit tayo. Again, class. 10, 8, 7, 8, 9, 10, 11, 9, etc. Okay, so ito yung time series natin. This is the latest. So ang autocorrelation class, it's just like correlation. Correlation class. So ang gagawin natin, correlation ng log1. Ibig sabihin class, yung log1 values, yung x sub t minus 1 natin. So this becomes 11, 10, di ba? 9, 8, 7, 7, and then 8, and then 10. Ibig sabihin, kukunin natin from yung log 1 ito. Yan yung log 1 natin, di ba? Yan. Yan ilalagay natin dito. Tapos kunin mo yung correlation nito. Siyempre, mababawasan ng isa dito kasi sobra tong original natin. So get the correlation. So this is the correlation, autocorrelation. Why is it autocorrelation? Kasi this is just the time series itself, di ba? This is not another variable. Okay, so gusto lang natin malaman kung correlated ba si value ngayon at saka yung value kahapon. Okay, because we would want to know kung ini-influence ba ng mga values ngayon yung future values in this particular one step. So we get the autocorrelation of that. So autocorrelation at log 1. Tapos kukunin din natin at log 2. So paano yung log 2? So ito naman magiging 10. So mangyayari class from 10 up, no? So ganito din yun. 10, 9, 8, 7, 8, 10. Okay? Kunyari marami pa yan. Okay, now kunin natin correlation itong original at saka ito. Kunin yung autocorrelation yan. Okay, so that's now your autocorrelation at log 2. Madali naman kunin yung autocorrelation class, no? Very simple lang yan. Sa core lang yan eh. Sa R, core lang yan. Etc. class. Sa log 3 din, log 4, depende kung hanggang ano log. Pag may seasonality class, baka hanggang, kunyari monthly seasonality, baka hanggang log 36, pwede natin kunin. So ano yung log 36? Hanapin mo yung pinaka pang 36, okay? Tanggalin mo yung from here up to 36 value, and then kunin mo yung pataas nun. Yun ang i-indicate mo dito. So gusto natin malaman yung pang 36 ba, 36 days ago, na-affect ba niya yung up to now, di ba? So pwedeng wala, no? Kasi masyado nang malayo yon. Okay? So yan, autocorrelation at log 1, log 2, log 3, log 4, etc. Okay, pause muna ako. Class, clear ba so far? Kung clear yung autocorrelation na yan? Clear class? Paki-chat nga kung clear yung pagkuha ng autocorrelation. Kaya lang naman lagay yung auto kasi same data lang din naman yun, di ba? Paki-chat class, please. Kung clear yung autocorrelation na yan. No questions? Okay. All right. So kunyari hanggang di ba ito, may value na tayo ng autocorrelation between your data and log 1. May value yan. Ito din may value. Yung data natin and yung log 2. Ito din yung log 3 at saka yung data natin. Okay, so that's easily computed kung tutuusin. Kasi kukunin mo lang yung log 1, log 2, log 3 hanggang ano. Now, ito yung problema, yung partial autocorrelation function. Si partial autocorrelation function, okay, medyo masalim yung ito kaya hindi siya madaling i-compute, no? Kunyari, okay, ang partial autocorrelation function, ang ginagawa diyan, kukunin mo yung autocorrelation at a certain log, tapos i-minus mo yung mga effects ng mga previous logs. Ulitin ko. Kunyari, tinitingnan natin yung partial autocorrelation at log 4. So, paano mo kukunin to? Well, kunin natin yung autocorrelation at log 4. Di ba meron na to, di ba? Na-compute natin yan kasi log 4 lang naman yan, correlation ng log 4 at saka nitong original data. So, yung autocorrelation at log 4, and then ima-minus mo. Yung autocorrelation ng 1, autocorrelation ni 2, at saka autocorrelation ni 3. Di ba mga values yan class di ba? Ang autocorrelation, value yan. Di ba? And correlation ba, is between -1 and 1. Correlation yon. Okay? Okay, so get the autocorrelation ng log 4 and then subtract mo si log 1, log 2, log 3. So imagine kung partial autocorrelation ni log 4. Partial. So you have to get the autocorrelation ng log 36 and then ima-minus mo lahat ng autocorrelation ng log 1, autocorrelation log 2, log 3, log 4 hanggang log 35. Tatanggalin mo siya. Okay? Okay? All right. So obviously, mas mahirap i-compute class si partial autocorrelation. Okay? Kasi kukunin mo yung ito, autocorrelation ng log 36. Yun na yun di ba? Kunin mo lang yung data, original data, at saka yung log 36. Kunin mo yung correlation yan. Si partial autocorrelation, log 36 autocorrelation minus autocorrelation ng log 1 hanggang log 35. Di ba? Imagine. So, in order to compute for this class, gumagamit ng special formulas called Yule-Walker. Ito yung sinabi ko kanina. No? Yule-Walker. Okay, don't worry, hindi natin i-compute manually ang klase. Imagine, kung kinuha natin autocorrelation function tapos log 36, ang tagal niyan. Alright, mukhang hindi tayo class. Okay. Mukhang hindi tayo So, sa kabilang section class, medyo nakatapos kami ng ano. In fact, ang natapos namin, tingnan niyo class yung sinend ko sa inyo na Sinend ko sa inyo na file. Okay, buksan natin yung class. Yan. Tingnan nyo class yung naabot namin. Yan, ito, hanggang ano lang nga tayo di ba? Hanggang step 6 lang tayo. Kami natapos namin hanggang dito class. Yan. Hanggang air passengers natapos namin hanggang dito. So, medyo malayo class yung pareho lang naman yung time na natin, no? Medyo malayo. So, since you have the codes class, no? I'm sure class you'll be able to understand. And then to put us in the same step as the others, kindly yun, if possible, yun ang panoodin nyo, no? Yung sa K30, K32. Okay, K32 class, yung Finch Leaves. Ipopost ko. Tapos, nga pala, naku, baka kung makalimutan, yung quiz nyo class sa yung face-to-face quiz natin, ang topic will be data and data structures and up to deployer. Lahat yan, select, filter, summarize, kasama yung joins. So, I would that you do some research about joins. Pero ipopost ko pa rin yung code ng joins. Alright, so that's Tuesday class. So, please don't forget to bring your laptops, okay? Canvas tayo, yung exam natin. Okay, so with that class, it's already time. I'm sorry we were not able to finish this. Yung time series class, hindi kasama sa exam sa Tuesday. It's not included, no? Ano lang, yung data structures, all about R, yung paggamit ng R for documentation, YAML, etc. until data wrangling. Okay? All right, thank you so much, class. I'll stop recording now.